In this video, I'm going to show you how to graph cosine functions, which are very similar to graphing sine functions. So hopefully you watched my previous video on graphing sine functions, because I'm going to kind of skip some steps here and go a little bit faster in this video. So again, to graph cosine functions, I like to use this little shortcut recipe here. If you can identify the amplitude in the period, and find and label what I call 5 key points, and then connect those points, you can draw the graph of a cosine function. So let's get into an example here. In general, the way that the cosine function looks is just like this. An a value is always going to be in front of your cosine function, and the b value is always going to be in front of your x value. So if we do the most basic cosine function, that's cosine of x, a is implied that it's 1 right here in front, and b is implied that it's also 1 right in front of the x. So we're going to find our amplitude and our period. Our amplitude is the a value. So in this function, our a value is just 1. So the amplitude is 1, and that will represent the maximum because it's a positive value. And that also allows us to draw our maximum value on our graph. The minimum value is going to be the opposite of that. So the minimum is going to be -1. 0 could be right in the middle there. And so now that we know our possible maximum and minimum values, or possible y values, we know the range of our function. And we could write the range starting with our minimum and ending with our maximum. And since we're talking about range, we're talking about y values. So the possible y values are going to always be in between -1 and 1 for the cosine of x. If we could find our period, we could label the x-axis. Period is going to be the full cycle, the full shape of the graph. And the equation for the period, to find the period, is always going to be 2 pi over b, the same as it is for sine functions. So sine and cosine functions have the same equation for periods. If you know your b value, you can evaluate your period. So the b value of this function is 1. So 2 pi divided by 1 is just 2 pi. So we know the end of our graph is going to be 2 pi. And we can put that on our graph at the very end. The last key points are always going to be a quarter of your period, half of your period, and 3/4 of your period length. For sine and cosine in general, we're going to start at 0 right here. That's going to be our input. And the inputs for trig functions are always angle measurements. So if I plug in an angle measurement of 0 radians into this cosine, I'm finding the cosine of 0. Well, the cosine of 0 is 1. So now we know where to start our graph. Let's figure out what the output when we end our graph is. If this is my input 2 pi, then the cosine of 2 pi is going to be 1. So now we know how our graph ends, and we just need 3 more key points. So this point is always going to be a quarter of your period. So 1/4 of 2 pi is 2/4 or a half pi. And if I plug in this input into this function, the cosine of pi over 2 ends up being 0. Now you can evaluate these based on your knowledge of a unit circle, or you can plug it into a calculator. You just have to make sure you're in radian mode, since we're dealing with radian angle measures. And so if you type in the cosine of pi over 2 in radian mode, it should give you an output of 0. Alright, next key point would be half of the period. Half of 2 pi is just 1 pi. And if I plug that in and evaluate, the cosine of pi ends up being -1. And the last key point is always going to be 3/4 of your period. 3/4 of 2 pi would be 6/4, so that would be 3/2 pi. And if I evaluate that, the cosine of 3 pi over 2 is always going to be 0. Alright, so we got all of the points we need on our graph. We start at 0, and if I input 0, I get an output of 1. So cosine graphs will always start at their maximum value. Then we move on to the next key point, which is pi over 2. And if I input pi over 2, I get 0. So 1/4 of your cosine will always be 0. Then I evaluate the next, which is half of our period, which is 1 pi. If I evaluate the cosine of 1 pi, I get -1. So that will always be, half of your period will always be the minimum of your cosine function. And then the last one was 3/4 of our period, which is 3/2 pi. When I evaluate the cosine of that, I get 0 again. And the last point is our full period. If I evaluate the cosine of 2 pi, I get +1 again. So now I just have to connect the dots to see that the shape of a cosine graph kind of looks like a cup. If you think back to the sine functions, it looks very similar. It's just kind of like we start at half of the sine function and we end at an extra half of the sine function, which is essentially what cosine is. But you don't have to know that. But definitely know that the cosine graph looks like a cup. And it always starts with the maximum value, goes to 0, goes to the minimum value, back up to 0, and then ends at our maximum value again. Alright, so that is kind of the pattern that we're going to use. Let's do a few examples. This first one here, we're going to find 3 times the cosine of 2 pi x. So let's follow our recipe here. We need to know what the amplitude is. Well, the amplitude is always in front of our trig function, so it's +3. So that tells me that the maximum is going to be 3. So I should know that the minimum is now -3. 0 is going to be right in the middle. Let's figure out the period length. Period is always going to be 2 pi over b for cosine and sine functions. So my b value is always in front of my x, so my b value is actually 2 pi. So if I substitute and simplify, I get 2 pi over 2 pi, which reduces to 1. So I know that my full period length is going to end on 1 there. And if I find my other 3 key points, I can finish my graph. So 1/4 of 1 is going to be 1/4. Half of 1 is going to be half. And 3/4 of 1 is going to be 3/4. So there's my 5 key points, and I use the pattern of my cosine graph to plug in my points. I know I start with my maximum, I then go to my 0, then minimum, back to 0, and back up to maximum for that cup shape. So there's our cosine graph for that function. Let's do one more here. This time, let's try this function. 2 times the cosine of 1/2 x. Amplitude's always the number in front of the trig function, so 2. So I now know that my maximum is going to be 2. My minimum is going to be -2. So my range will be in between -2 and +2. That shouldn't be there, sorry. That should be 0. Alright, let's figure out the period length next. so we can plug in the points on our graph. Period is going to be 2 pi over b, and the b value is 1/2. So 2 pi over 1/2, if we remember how to divide fractions, we're going to flip and multiply. So we got 2 pi times 2 is what this actually is. And we end up getting 4 pi. So our period length is going to be 4 pi. I can put that at the end of my graph. And then I can figure out the last 3 key points. 1/4 of my period would just be pi. Half of my period would be 2 pi. And 3/4 of my period would be 3 pi. And then use the pattern of our cosine graph. It starts with our maximum, then goes to 0. Half of our cosine graph is always the minimum, back up to 0, and we always end with our maximum. And again, we get the nice cup shape. Alright, so that's graphing cosine functions. Somewhat similar to sine functions, except for the shape of the graph. But the method is still very similar. So good luck graphing cosine functions. And in my next video, we'll talk about graphing tangent functions, which are the trickiest of them all.